Today we are finishing up our 2.4 notes that were started yesterday. We finished yesterday with creating 3 graphs at the bottom of our second page. This is something, I just quickly redrew it for us. So that's what our graph should look like, right? Okay, so if we go on to our third page on question 4, it says, do the y values increase, decrease, or stay the same as the x values increase? So they told us our x values, I'm going to switch the page now. They told us our x values are going to be increasing, which means they're going to come from, let me move this down, which means our x values, this is our x-axis, so they're increasing. So if this is our negative side, they're going to be increasing and going to the right. So as our lines are going from the left to the right, negative to positive, increasing, what is our y doing? Is it increasing, is it decreasing, or is it staying the same? So we're going to look at plan 1. So if I go through left to right, what is my y-axis? My line, looking at my line, what's my y-axis doing, Robert? It is increasing. So as we go from this way to this way, looking at my line, it is a positive line, increasing. Whoops, I went the wrong way. So plan 1, we can just write increases. Going back to our table, plan 2. Oh, I don't know what I just said. Oh, I erased it. Okay, now that I remade the lines, we can look at our plan 2, and as our x-axis is increasing, which means it's going from the left in the negative area, and it's moving to the positive area, what is my y-axis doing? Lily? It is decreasing, exactly. So our plan 1 is increasing, and plan 2 is decreasing. Lastly, we got to look at our plan 3. That line looks a lot different. What is this line doing? My purple line. Sophia? Staying the same. As this is going right, my x-axis, as that's getting positive, my y-axis isn't doing anything. It's staying at the same number at a positive 2. So we would just say, stay the same. So we're looking at the direction that those lines are going in. As we keep going, it says, explain how you can answer the questions using a table, graph, or an equation. So using a table, how can we answer that question that we just answered in question 4? How can we answer that question looking at a table, Gavin? Well, let's look at our table that we created on this last page. Gavin, how can I create this? I have negative 28, negative 23. Our second page. Gavin, how can I see what that's doing? Well, they said as my x is increasing. Here's my x, and here's a negative. If I look, it's going to a positive, so it's increasing. What is my y doing as it goes right? We can see that it's increasing also because we started at a negative 28, and we ended at a positive 22. So, to explain this in a table, we can say that as the x values increase, I'll do an upwards arrow for increasing. Look at the corresponding y value. And see if it gets bigger. If it gets bigger, which we said it did, it went from negative 28 all the way to a positive 22, then it's increasing. If it's staying the same, then the number's staying the same. If it's getting smaller, then it's decreasing. Looking at a graph now. We basically did that already. Now we just want to explain it, Joey. How do we answer that question looking at a graph? Where the line starts and where it ends? Yeah. So it's basically more about looking at the direction of the line, would you say? Yeah. So we can say that you can look at the direction of the line. Good job, Joey. And then lastly, our equation. We have that equation. Lily, you want to answer it? How?
Negative number in it, it could decrease, but if it doesn't have a negative number, it's increasing.
Okay, you're on the right track. It'd be the same number, but when we're looking at an equation, how are you going to determine whether those numbers are increasing, decreasing, or staying the same? Are you going to plug in numbers for them, or how are you going to determine that? Yeah, we have our y equals mx plus b, and that's what the equations are in. We have y equals 5x minus 3, y equals negative x plus 6, and y equals 2. The way to see whether it's increasing or not is pick an x value. Say 2, negative 1, 5, anything you want, and then solve for y. Get y by itself, solve for y. And then say, when you plugged in negative 1 for x, your y ended up being 2. That's fine. Now pick a greater value of x. So if we picked negative 1, you can pick 0, you can pick 5, you can pick 15, anything greater than that, and then solve for that number. We'll compare those two y's that you found. Is the second one larger than the first one you found? Is it the same as the first one you found? Or is it smaller? Do you see what I'm saying there? So in this equation, say I had the y equals 5x. What was one of the equations? 5x minus 3. Okay, that was one of our equations. If I plug in y equals 5, 1 minus 3, what do I get as a y? 5 times 1 is 5. Minus 3 gives me 2. Okay, so I know these values are 1 and 2. So now I want to plug in a number greater than 1. So what number do you want to pick? 0 is not greater than 1. Say another one. 3. I can do 3. So y equals, what's 5 times 3? 15. And then minus 3? 12. So my y equals 12, which means when my x's increased from 1 to 3, did my y's increase, decrease, or stay the same? They increased. So that's how you can determine it by just looking at an equation. That means just plotting some points in the equation. So yeah, you're basically plugging a number in for x and figuring out what your y is. You have to do it twice to be able to compare some. So that's all you would do for the equation. Put a value in for x and solve for y. We can just say compare the two y values. Part B, which pledge plan's graph contains the point 2, 4? 2, comma 4. With your shoulder partners, we have tables, we have graphs, and we have equations that we did from yesterday. You can use any of those three to determine whether your coordinate 2, comma 4 is on that line. Is it on the line with plan 1? Is it on the line with plan 2? Or is it on the line with plan 3? About 2 minutes sound okay? All right, 2 minutes. Okay, we're back up here. Brayden, what plan did you find? Plan 2. Okay, what form? How did you find that?
I looked in the table and I just kind of went down and I saw that like scoop is the X and 4 for the Y.
Oh, that's a great way to do it. Let's see. If I have 11, 10. So you said you looked at all of these tables?
Yeah, I went down. So I kind of looked down to see if it was or not. And I found that.
Yeah, so the question was, which Podge plan contains the point 2, comma 4? That means that coordinate 2, comma 4, which line goes through that coordinate? It could be this graph's line, it could be this graph's line, or it could be this graph's line. One of them goes through that point 2, comma 4. So Brayden said he found that by looking at his tables. So right over here, he looked at x has to be 2. Is your y 4 for plan 1? No. What about plan 2? X has to be 2 because they told us that, and our y has to be 4. Is that one true? Yeah. What about our last one, plan 3? X has to be 2 and our y has to be 4, but is y 4? No. So Brayden just was able to do elimination there to find that plan 2 is the only one that's correct. Very good. Who got plan 2? Hand on your head. Awesome. Good job, guys. Going on to question 2, it says, how do the coordinates 2, comma 4, we're working with the same coordinates, relate to the equation of the line? To the table, how does it relate? So we're basically saying, what does it mean? When we're looking at the equation, we know that the point 2, comma 4 is a solution, which means it's a point on that graph, on that line. Solution, we can say, of the equation. So to show that, if you plug 2 in for x, you can solve what your y is, and you will get 4 for y. That's in our plan 2. Our plan 2's equation was y equals negative x, was it plus 6? Yeah, plus 6. So if I plug in a 2 in for my x, and I solve for y, my y should be 4. If not, then that plan's not correct. It doesn't go through that plan. In this case, we know it does because we looked at our table. You will get oops, sorry, I'm writing this wrong. You will get the number 4 for your y. Any questions as to how you could do that? That's your equation. What about our table? How could we find it for our table? Brayden basically told us. So what did Brayden say? Brayden, can you explain that again? We're just going to write it in words now. Yeah, so if 2 is the value in the x column, right? You found where your x was 2. So if we look in the x's and find where it's 2, then the corresponding y will be 4. So when we found our 2 on the x in our table, we looked right across and said, hey, what is that number, that value in for our y? It should be 4 if we use the plan 2 equation. If it's not, then it must not be plan 2's equation. Any questions as to how we did that before we go on? No? This says write a question you could answer by locating this point. Write a question. Yesterday, Lily made a question for us. We can have any question we want, anything you want. What kind of question does someone want to put? Maria? Oh, that's a good question. If 2, 4 is on the graph, would 4, 2 be on the graph? I like that, Maria. You can have any question you want, any kind of question. You can't be wrong here. Part C, which relationship has a graph you can use to find the value of x that makes 8 equal 5x minus 3 a true statement? 8 equals 5x minus 3. Well, what plan is that using? What equation? Which plan's equation? 5x minus 3. Anthony Coleman. 5x minus 3 is what plan? 1, 2, or 3? Plan 1? Yeah. So it says, which relationship has a graph you can use to find the value of x that makes 8, well, let me scroll this down, that makes 8 equal 5x minus 3. Well, we know that our 5x minus 3 is part of our plan 1 equation. All they did here, our real equation is y equals 5x minus 3. All they did was plug in an 8 for their y. And they want us to use that 8 and y and solve for their x. Get x by itself. It's doing the opposite as what we were doing before. Before we plugged in a number for x and we determined what our y is. Now they gave us an 8 for our y and they're saying, hey, find what x is. And based on the equation, we know that we can use plan 1 to figure that out, to figure out if that statement's true. When 8 equals y, what is x? We can't use plan 2 because their equation is y equals negative x plus 6. That equation doesn't even correspond with how this is set up. Why would we use a random equation when we're basically given most of our plan 1 equation, right? For question 2, it says, how does finding the value of x in 8 equals 5x minus 3 help you find the coordinates for a point on the graph? How does that help you? With your shoulder partners for 2 minutes, talk about how that can help you. How does finding the value of x help you to find the coordinates for a point on the graph? Well, they told us our 8 is y. We have no idea what x is, so can we graph that? Not yet. Talk about that with your shoulder partners, how finding the value of x here is important before you can graph it. Question 2 says, how does finding the value x in 8 equals 5x minus 3 help you find the coordinates for a point on the graph? Well, as of right now, can we plot that point? Right now we have this, x comma 8. Can we plot that? Do you know how to plot that on the graph?
Yes.
You can? Well, you don't know that yet, do you? You had to solve that to get to that, didn't you? Yeah. So once you find, Robert's a step ahead of us, and he actually found what x was. Once you find the value of x, then you know the coordinates. For the point x comma 8. Then you know the coordinates for that point x comma 8. So once you solve for what your x actually is and you find an actual number, then you can take whatever that equals, whatever your x equals, and actually plot that point on your graph. But right now, having x comma 8, you can't do that. It's impossible. Unless you just made the number up, which isn't correct then, right? They want to know if this is true. So then again, finding the value of x when y equals 23. On our second page. Is everyone done writing this down?
Yeah.
I'll keep it up for another minute. On the last page, though, it says find the value of x when y equals 3. They want to know how we would do that using our table, our graph, and our equation that we've been working with. Before we had the value of 8. Now we have... Did I miss a page? Oh, I did miss a page. Right here. The following 3 points all lie part D. I missed the whole page. The following 3 points all lie on the graph of the same plane. Of the same plane. 7, negative 7, comma 13. 1.2, comma something, something, comma negative 4. How can we determine which plan this lies on? Based on the information they gave us, Robert. We can look at our table, and what are you going to look for in your table? Did I say plane? Oh. Oh. Yeah, I can't remember what I said. I might have said plane or plan. Yeah. So, these 3 points, what plane are they on? Are you going to look at your plan 1, plan 2, or plan 3? Robert, you said you're going to look at your table. With a negative 7, comma 13, did we plot that on our table? But can we? We still can. We can still make those points further. Because we just did negative 5 to positive 5. But we can make it go all the way back to negative 7. So why don't you plug that number? We can plug that in to our equations. Let's try equation 1. Y equals, what is our, 5x minus 3. 5x minus 3. If I plug in our negative 7 for x, 5 times negative 7 minus 3. I'm going to plug it into each equation to figure out if it equals 13. What's 5 times negative 7? And then that minus 3, negative 35 minus 3. So is that 13? No, so it's not plan 1. What about plan, what is the plan 3? Y equals 2. Well, is that negative 7 comma 13? No, because we don't even have an x value in there. Because they're all y equals 2. The whole line. So our plan 2, which is y equals negative x plus 6, if I plug in our numbers, what's a negative 1 times a negative 7? 7 plus 6. So using the points in this equation, I get negative 7 for my x and 13 for my y. So what plan would we use? Exactly. We would use our plan number 2 since negative 7, 13 lies on the graph. Question 1 in our part 2. 2 of the points have a missing coordinate. We see that right up above. Find the missing coordinate. Explain how you found it. Okay, so they want us to find what our y is, because we know these are written in x comma y. Our x is 1.2, and now that we know what equation we're going to be using, our plan 2 equation, y equals negative x plus 6, how would I solve what my y is? I know my x is 1.2, and using this equation, how would I solve for my y? Ava? How would I solve for my y right here? Yes. Plug it in for x. So 1.2 would end up being our negative plus 6. So negative 1.2 plus 6 gives you what? When we add those on the calculator, y equals 4.8. So right here, we can plug it in a 4.8. Again, with our next equation, this time we have our y and we need our x. So I'm going to plug in, what is it, negative 4? Or negative 4. In for my y and solve for x. How am I going to start doing that? Peyton, how would I start doing that to solve for my x? I got to get x by itself. Combine your numbers together. So I have a plus 6 over here. So to move it over to the other side, I have to do the opposite. Yeah, I'm going to subtract 6 to both sides. That cancels out. Negative 4 minus 6. It's becoming more of a negative. So what is it? Negative 10, exactly. Equals negative x. Well, that's not a positive x. I want a positive x. So I have to do one last step and divide this by negative 1. That cancels out and gives me x equals negative 10 divided by negative 1 gives me what? A positive 10. So that's what I would put in place over here for x. 10 comma negative 4. That's how you find those values when they give you just one variable. And then one last time, it says write an equation you could answer by finding the missing coordinate of x comma negative 4. Write a question. Write a question. So who wants to create another question for us about finding our x? Lily, did you want to?
Would our answers still be the same if the x was negative 4?
Okay, I like that. Would our answers still be the same if our x was negative 4? Oh, that should be a question, not a period. Okay. Good job. Part E, question 1. Describe how a point on a graph is related to a table and an equation that represents the same relationship. So if I'm given a point on the graph, say the point 2 comma 4, my line goes through 2 comma 4 on a graph. How would that be expressed in the table? Lily?
You would find the value of x in the x column.
Yeah, you would find the value in the x column. What these are called in your graph is that the point on the graph is an ordered pair, Lily. An ordered pair is what our x comma y is. That's what we call that. So when we say that, this is what, going off of what you said, the ordered pair corresponds to the two values in the columns. In the columns. And the equation. How can you find it in the equation? A point that is plotted on the graph. Becky. Explain how you can find a point that is on a graph and how it's expressed in an equation. No, we're just looking at our equation, not the table. We're looking at a point. Say our point 2, 4 is on the graph. How does that represent? How is it represented in the equation? If we're given y equals negative x plus 6, that's our equation. And I say 2, 4 is a point on your graph. Can you plug that into your equation? Yeah, because you know the ordered pairs. So it's based on knowing the ordered pairs. The ordered pairs is a solution for the equation. And again, our ordered pairs are the x comma y. That's how it's expressed. 2, how can you use a table, a graph, and an equation to represent y equals 5x minus 3 to the value of y when x is 7? So they told us x is 7. And they told us you're going to use this equation. What is your y? We kind of did this already. They've just given us different values now. So when you have the equation y equals 5x minus 3, and you know your x is 7, how are you going to determine what your y is when looking at a table? How are you going to determine the value of y? Robert was kind of saying this earlier. Do you want to share it again, Robert? When you're looking at a table and you know your x is 7, you can say to find the y value, what are we going to do with that table? Lily? Yeah, you're going to plug in 7 in for x for y or 7 for x? 7 for x, yeah. Locate the 7 in the x column. See where 7 falls on your x's. And see the corresponding y value. Exactly. And then again on a graph. We can do that because we know that we can locate 7 on the x-axis to see what the y value is on the y-axis. We can follow that 7 up on our x-axis and see where it crosses our line, and then we can take that across to our y to determine what that y point actually is. So the point would be really expressed as 7 comma y, 7 comma whatever y is. That's written as an ordered pair. And then lastly, we did this with our equation. We already solved it. So when we're given an equation and we're given one of the values, we can find the other value by plugging in that number. So if I substitute 7 in for x in the equation, and simply just solve for y, like we were doing at the top of this page. We're going to do this one last time on the last page now. But this time, Maria. Yep. Is that good? Okay. So this time, we were given a y. We said y equals 23. How do we find what our x is? That's what they want to know. Well, when you're looking at a table, and when you're looking at a graph, and when you're looking at an equation, and you're given the value of y, which equals 23 in this case, how are you going to find the x? It's basically going to be the opposite as to what we just talked about. So, Stephanie, when we have a table and I told you the value of y is 23, how are you going to see what your x is? Is everyone good on this page? No? Where? Like right here? I'll give you a minute to finish writing this down. Okay, let's get these notes done. Everyone should have that down. So when we want to find our x, we know y is 23. Looking at a table, Stephanie, how am I going to do that? Yeah, exactly. Find the value of 23 in the y column. Find where that is. And see the corresponding x value. Just see what it is. Then going on with the graph. How am I going to do this with the graph, Maria? When I know my y, when they have a line and I know my y is 23. Where what? Yeah, x23. Yeah, so you want to locate where x23, x comma 23. And how are you going to do that? You're going to look at that line, see where your y is 23 on the line that they created, and determine what that x value is. So once we find that point, we're going to see what the x value is on the x-axis. And lastly, I'll answer this one for you. The equation. We can simply plug 23 in for x, or for y, I'm sorry, in for y in the equation and solve for x to find what x is. So that would be more like saying 23 equals negative x plus, what is that equation? Negative x plus 6. Bless you. We do. We'll talk about it in a minute. Okay, here's our summary. This goes over all of the points on a graph, ordered pairs, finding values of x and y together and substituting them. Look over all of these before our quiz. Look over all of these while you're doing your homework. This is basically a summary as to what we are going over. That is it for our notes for today.